These are the top 50 organic questions you have to solve before getting into examination. These 50 questions will give you the entire coverage of organic chemistry for your JEE Main. Let's get started with this question. We have to match column A with column B, like list 1 with list 2. First reaction, which is phenol is producing salicylic acid. Second one, phenol is giving salicylaldehyde. Phenol is undergoing to give oxidized product, and D, phenol is giving OCH3 product. Okay, let's see one by one. Out of this, what we know, the first one, this is undergoing oxidation. So what are the reagents we have as an oxidizing agent? So this is an oxidizing agent, right? So C belongs to 1. And then what about B, which is Reimer-Tiemann reaction? B is a Reimer-Tiemann reaction. So B is 3. And what about A? A is cold synthesis, right? So A belongs to 5 and D is 2. So NaOH will first produce phenoxide and then CH3Cl. Na will take up the Cl and then CH3 will attach over here. Okay, so this is the right answer to this question. Moving on to the next one, phenolic group can be identified by a positive, which is C6H5OH group, right? So if I have Thallium dye test, that is for identification of phenols, right? And Lucas test is primary, secondary and tertiary alcohols. Tollens test is for aldehydes. And carbylamine test is for primary amines, right? So the answer to this question is Thallium dye test. The next one, phenol treated with chloroform in the presence of sodium hydroxide. Phenol with chloroform and sodium hydroxide, which further hydrolyzed in the presence of acid results. What is this reaction? Obviously, Reimer-Tiemann reaction. Remember? So first chloroform will form an carbene and that will attack the phenoxide ion. Not phenoxide, the second position over here, and then the product will be formed. So what are the options given over here? That is salicylic acid, benzene 1,2 diol, benzene 1,3 diol and 2-hydroxybenzaldehyde. So the answer to this question is 2-hydroxybenzaldehyde. Given below are the two statements. Statement 1 is para-nitrophenol is more acidic than meta and orthonitrophenol. And statement 2 refers ethanol gives immediate turbidity with Lucas reagent. In the light of above statements, choose the correct. Okay, so first statement says para-nitrophenol, comparing it with ortho and meta. So para-nitrophenol, which is because of the resonance stabilized structure, this makes it more acidic than compared with ortho and meta. So ortho, as you can see, which can give hydrogen bonding. So hydrogen can't leave very easily, and meta also, which is not much stable in the acidic form. So para-nitrophenol, that is more acidic than other two. This is true. What about ethanol will give immediate turbidity? So ethanol is an primary alcohol. Immediate turbidity to Lucas test is works for tertiary alcohol, not primary, right? Lucas test with the anhydrous zinc chloride, yes. So that will give you immediate turbidity for tertiary. And for secondary, that will give you turbidity after 10 to 15 minutes. And for primary, with upon heating. Mostly it won't react, right? So, which is the right answer? Statement 1 is true, but statement 2 is false. Salicylaldehyde synthesized from phenol when reacted with. So this is asked in 2024 paper. As you can see, what is this reaction? Reimer-Tiemann reaction, right? See how many times that particular named reaction were asked in previous year papers. So obviously answer to this question is CHCl3, chloroform with NaOH. And let's move on to the next question. Given below are two statements. One is labeled as assassin A and the other is labeled as reason R. Okay, assassin is alcohols react both as nucleophiles and electrophiles. Alcohols react with active metals such as sodium, potassium, aluminum to yield corresponding alkoxides and liberate hydrogen. So which is right? So that's our question. So this is straight from NCERT, right? So as per NCERT book, if you have thorough with it, you know this answer very well. Assertion A and the reason R is correct, but reason is not the correct explanation for the assertion A, right? So this is also right, this is also right, but this will not prove, this will not explain the statement A. Then next question, they have given C ester treated with concentrated HBr. What is the major product formed over here? Let me take this reactant CH3OH double bond C double bond O OCH3, right? So HBr, first of all, what that will give? H plus, right? So the H plus will obstruct the OH minus, right? So remaining what I can expect is there will be a plus charge over here, correct? So that plus charge can be neutralized by so there will be a plus charge produced on that carbon. After OH leaves the compound, I'll be having a plus charge, remaining C double bond O OCH3. So this plus charge will pull the electrons. Due to that, it will form a double bond over here and CH2 with the positive charge, correct? So that positive charge will attract the Br from HBr. So answer to this question where I'll have CH2Br over here. So which makes option B as your right answer. Moving on to the next question, given below two statements, one is labeled as assertion and reason. pKa value of phenol is 10, while that of ethanol is 15.9. The reason is given that ethanol is a stronger acid than phenol in the light of above statements. Okay, so let's understand these two statements. We know that ethanol is not much stronger than phenol, right? Because phenol has resonance stabilized structure, but ethanol doesn't. So, which makes the answer is A is true, where phenol is having 10, because always remember pKa is inversely proportional to acidity. And acidity is directly proportional to Ka. Ka is inversely proportional to pKa. Okay, so phenol is having lower value, which means higher acidic than ethanol. Next question, A and B form the following set of reactions are. First one, alcohol, and also I have another alcohol over here, and the second one OH with OCH3. So which the options are given over here, A and B. Check this out, and what would be the answer for this? Let's solve step by step. First I have this OH in the meta position. I have this primary alcohol. With HBr, what we can expect? OH, this OH obviously will get replaced by Br to SN2. So CH2Br will be formed, right? Next, what about the second one? Here I have OCH3 OH. So this OCH3 with HBr. First Br will take up the CH3 part, then OH, that is the positive part over here, that get attracted to OH. So answer to this question is option D. Asking about the product X formed in the below reaction is. Okay, so what are the reagents used over here? NaI and H3PO4 and magnesium triether and D2O. Not H2O, D2O. This is where you have to use the mechanism part. Let's see. So first of all, this will react with NaI and H3PO4. So what that can give? Obviously, iodo-substituted product. Then this with magnesium triether. So the whole thing will get converted to Grignard reagent, right? Consider this as an R group, magnesium, and this is X, right? So which will be C2H5 CH Mg I CH3. Then hydrolysis. It's not hydrolysis, it is when RMGX is treated with water. So we have seen this so many times. What will be the product? MgI is there. So which will produce the product as CH2 Mg will take up the OH part. Remaining I'll be having CH D, this D2O, right? So DCH3. Remaining I'll have Mg, OD and I. So first of all, this is a simple free radical reaction, isn't it? Br2 H nu gives the major product. So they have mentioned that the major product of the following reaction. So only one Br2 is involved over here, not in excess. So how many products can be formed? So let's number this compound. Let me draw it again. So let's number this one, Br2 addition, where we can expect this. Let's number it. How many carbons do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So with Br2, what we can expect is one of those hydrogen will get replaced by Br, right? That is monobromination. So 12th and 13th carbon. This carbon and this carbon are not taking part in the resonance. All other carbons are taking part in the resonance, and the lone pair of oxygen is also taking part. So as the resonance stability of the compound increases, bromine will not attack to any carbon which is taking part in the resonance and decrease the stability of the compound. Right, so all those organic compounds, all those compounds basically going towards the stability. So if already that is more stabilized because of the resonance, why bromine need to attack that position, right? So bromine can attack only these two carbons, but 12th carbon is an alpha carbon and it can easily donate H plus ion. So the major product, if they are asking, then the answer would be in this part, I'll have a Br. Remaining would be the same. Next question, here I have OH group and treated with tosyl chloride with pyridine, NaCN and DMF. Okay, so replacement is simple. Tosyl chloride will replace the OH2Cl and then NaCN will replace the Cl2Cn. But what they are asking is, look at the options. They are asking whether above the plane or below the plane, what is the ratio selectivity. So let's see. Let's have this diagram drawn, which is OH is above the plane. Okay, now I'm adding tosyl chloride with pyridine. So first of all, what will happen? It will occupy this position, right? OTS. Cl will take up the Cl. H hydrogen will take up the Cl. Remaining one will be the same. Then now Cn have to attack. I'm adding NaCN. So if Cn want to attack, already think about the tosyl group. The whole system is tosyl. Okay, so that is so bulky. Obviously, it can't attack from the front. It have to go from the back. So it have to go below the plane. So the product will be behind the plane Cn, and this one will be as usual. So answer to this question is option. These both are same. I mean, both are in the above the plane setup. Here both are in the below the plane. So option B is your right answer. Which among the following halides will generate most stable carbocation in the nucleophilic substitution reaction? So as you can see, Br, it will create a positive charge over here. That positive charge will be neutralized by this double bond group. So it will be CH2 plus charge. Then here CH2 with plus charge. Again, this position I have phenyl group with Br. After Br left the compound, what will be remaining? Tertiary carbocation. Right? And here you can see after Br leaves the compound, I'll be having a carbocation like this. This carbocation, which is stable because of the resonance, that is having only one benzene ring with this. But imagine here I have 3 phenyl ring with this, right? So that can undergo lots of stability, that can give lots of stability to the compound, which makes option C as your right answer. When neopentyl alcohol is heated with an acid, it's slowly converted to an 85:15 mixture of alkene of A and B respectively. So first, let's take a neopentyl alcohol. So neopentyl means all 4 hydrogens of methane is occupied by the R group, right? So here I have CH2OH and remaining of CH3. Heated with an acid. So obviously that will be a H2O elimination. First happens in the presence of acid. So OH will get eliminated from the compound. Remaining, what do I have? CH2 with plus charge, correct? Then there is no hydride shift possibility, right? Because if I'm moving the hydride also, then the product will be the same. Again, CH2 will get a positive charge. So what this will do? This will do a methyl shift. It will do a rearrangement to form a methyl shift like this. Okay, so the rearrangement happens. After that, what we can expect? Obviously, it will produce either hydrogen can leave from this CH3 or from this CH3. So the product will be double bond with CH2, CH3, or you can expect double bond over here and CH3, right? So according to Say-Step rule, which is major? More substituted alkane will be major product, which is 85 and this becomes 15. Okay, check for the hydride shift, hydrogen possibility first, then go to methyl group. So lowest, lightest particle, lightest element should move first. Then amongst the following alcohols, which would react fastest with the concentrated HCl and zinc chloride? So what is this concentrated HCl and zinc chloride? That is Lucas test. Remember? Zinc chloride, anhydrous zinc chloride and HCl. So 1-pentanol, this is in primary alcohol. 2-methylbutanol, 2-methylbutanol is in secondary alcohol. 2-pentanol, that is again a secondary alcohol. Then 2-methyl-butane-2-ol, right, which is in tertiary alcohol. So which makes option D as your right answer. Sodium phenoxide, when heated with CO2 under pressure at 125 degrees Celsius, yields a product which is on acetylation produces C. The major product C is. So first of all, what is this reaction is? Sodium phenoxide with CO2 at 125 degrees Celsius, which will give you whole synthesis, right? So OH and COO-Na, which on acetylation first it will produce salicylic acid, then acetylated product, which is OH group hydrogen, will get COCH3 COOH. So that is, what is the name of this compound? Special name? Acetyl salicylic acid. I know. What is the special name? What is another name? Aspirin. Remember this compound? Sometimes directly they may give you as a question. Aspirin is produced from. So you have to know what is the structure of aspirin. In a given structure, number of sp2 and sp hybridized carbon atoms present respectively are. Okay, so let's analyze this. First of all, this is not our major concern, CH3, and then we have here double bond O, that is sp2, and double bond sp2 again, sp2, and this is CH2, not our concern. Then this is triple bond, so sp, this is sp2, this is also sp2, and carbon with cyanide carbon, that is sp because of the triple bond. So they are asking about carbon atoms only. Fine. So just count number of sp and sp2. We have 3 sp and 5 sp2. So 3 and 5 is the answer to this question. In the following reaction, the correct statement for product B is. So product B is formed from propanol and methanol. Okay, both are aldehydes with dilute NaOH heat and then NaCl followed by hydrolysis. You definitely know what is this reaction, right? Don't say you don't know. Propanol, CH3, CH2, CHO, and methanol, HCHO. So one of these having alpha hydrogen in it. So which makes it aldol condensation. We have heat also, right? So which will form an alpha beta unsaturated aldehyde. Followed by NaCN. So CN, which will attack on the carbonyl carbon. Let's write the reaction over here. CH3, CH2, CHO plus HCHO gives our CH3, C. This is my alpha carbon. Double bond CH2 with CHO with NaCN that will attack the carbonyl carbon, right? So which will create CH3 double bond CH2 C O minus hydrogen and Cn. Na will maybe occupies over here, then followed by hydrolysis. So upon hydrolysis, cyanide will give you carboxylic acid. So CH3 C double bond CH2 CH COOH. Right? So this is our product. But the question asked is, which of these are correct statement according to B? Optically active and adds one mole of bromine. B is racemic mixture and is neutral. C, racemic mixture and gives a gas with saturated sodium bicarbonate solution. And optically active alcohol, and this is neutral. So as you can see, for adding one more bromine, this is optically active. I have the carbon which is attached with 4 different groups. It's not neutral, this is acidic. And have this racemic mixture and it gives a gas with saturated sodium bicarbonate. So that is the correct answer. It's an optically active alcohol and it is not neutral. A also seems to be right. Adds 1 mole of bromine because I have a double bond over here. So mostly the sure short answer will be option C. While estimating the nitrogen present in an organic compound by Geldahl's method, the ammonia evolved from 0.55 grams of the compound neutralized by 12.5 ml of 2 molar sulfuric acid. The percentage of nitrogen present in the organic compound is. So here ammonia is neutralized by sulfuric acid. So milliequivalents of sulfuric acid used by ammonia, that is equal to 12.5 of 2 molar solution. So we are taking 25 milliequivalents, and percentage of nitrogen present in the compound 25 milliequivalents to 10 to the power minus 3 into 14 for nitrogen divided by 0.55 into 100 for percentage. So I am getting 63.6. So we know that milliequivalents of sulfuric acid, which is equal to milliequivalents of ammonia. So milliequivalent or millimoles of nitrogen, that is also equal to 25, right? So moles of nitrogen, millimoles of nitrogen is 25, moles of nitrogen is 25 into 10 to the power minus 3. So weight of nitrogen, that is 14 into 25 into 10 to the power minus 3. Percentage of nitrogen, that is equal to weight of nitrogen, that is 14 into 25 into 10 to the power minus 3 divided by 0.55 into 100. So which I'll get 63.66. So approximately 64%. Okay, 64 is the percentage of nitrogen present in the organic compound. In this Glycine-Schemant reaction to prepare dibenzyl acetone from 5.3 grams of benzaldehyde, a total of 3.51 grams of product was obtained. The percentage yield of this reaction is. First, let's understand what is this Glycine-Schemant reaction. So here we have to take benzaldehyde with acetone I'm taking because the product is dibenzyl acetone. So the product formed, that would be C6H5, CH double bond CH, bond C, H double bond O, CH, C6H5. Okay, so as you can see, this is in 2:1 ratio. So we know the product formed, that is 3.51 grams. What is the theoretical yield? That is in 2:1 ratio. So 5.3 grams of benzaldehyde. The molar mass of benzaldehyde, that is 106, right? So the moles which is taken 5.3 divided by 106, that is 0.049. So for 1 mole of benzaldehyde, half mole of products are formed, 2:1 ratio. So for 0.049 moles of benzaldehyde, half of that, right? So this will produce half of it, that is 0.024 moles of product must be produced. So that is how many grams? So mass of product, moles into molecular mass. So 0.024 into the molecular mass of dibenzyl ketone, 234.29, so which will give you 5.8 grams. So 5.8 is my theoretical yield. So what is the percentage yield now? Actual yield, that is 3.51 given in the question, and what we have find 5.85 supposed to form. So the yield is 60%. Compound which gives positive to the Felling's test are. So Felling's test usually given by the aliphatic aldehydes. Right? So let's see what are the aldehydes we have in the option. We have in the category given. First one is benzaldehyde, which is not give positive to Felling's test because that is aromatically stabilized. So the resonance stabilization is there. And the second one is ketone, so which will not here. And the third one, Felling's or tolerance, it's basically an oxidation, right? So this one have the primary alcohol which will oxidize to give aldehyde, so that can give Fehling's test. And the next one is acetaldehyde, that can also give. Next one is benzyl aldehyde, so CH2 CHO, so that can give Fehling's test. So C, D and E can give Fehling's test. Match list 1 with list 2. RCN SnCl2 HCl forms aldehyde. What is this reaction? It's straightforward question. Very straightforward question. If you know the name and the reaction, then okay, then you can answer it very well, or else just skip this question. SnCl2, while teaching aldehyde, I told you, start with SN, so Stephen, right? And BD with BaSO4, none other than Rosenmund. Then CrO2Cl2, etad reaction, and this one is Catterman course. So very straightforward question based on the named reactions. Both acetaldehyde and acetone individually undergo which of the following reactions? So iodoform reaction, Cannizzaro, aldol condensation, Tollens and Clemmensen reduction. Acetaldehyde and acetone individually we have to check. So iodoform reaction means, I told you what is the condition. The next group must be in CH3. So here I have CH3, so both the things can undergo iodoform reaction. Then Cannizzaro. Cannizzaro, no alpha hydrogens are allowed. Here I have alpha hydrogen, so which can't undergo Cannizzaro. Aldol condensation, it requires alpha hydrogens. So both can't undergo aldol condensation. Then Tollens test. Tollens test is for aldehydes, not for ketones. So both can't undergo. Only acetaldehyde can undergo Tollens test. Then Clemmensen reduction. Clemmensen reduction, this part will get converted to CH2, right? So CH3 will be formed here, and here CH3, CH2, CH3 will be formed over here. So what is the answer to this question? A, C and E. These are the answers. Then cyclohexylamine, when treated with nitrous acid, yields P. Cyclohexylamine treated with nitrous acid yields P. On treating P with PCC results in Q. When Q is heated with dilute NaOH, gives R. So what is the final product R? That's our question. So first of all, what is the first reaction with nitrous acid? That is diazotation reaction. Remember, NaNO2 with HCl, that produces nitrous acid. But here you see this is an aliphatic amine, not aromatic. So it will not give you the benzene diazonium salt kind of thing. This will immediately form an alcohol. So the alcohol formed, that is P, that's this. With PCC, PCC is a mild oxidizing agent, so which will give you the aldehyde group. Then NaOH. When Q is treated with dilute NaOH, we get the final product. This aldehyde or any carbonyl group, this can have the alpha hydrogens in it, right? So with NaOH, that will give aldol condensation to give the product as double bond O, 2 of this to produce double bond O. The next position, alpha position, I have this another group. So this is the answer to this question. Among the following, the number of compounds which will give positive to iodoform reaction. I told you iodoform is for, it should have a CH3 group, only CH3 group next to the functional group. So 1-phenylbutanone, 2-methylbutane, 2-all. These alcohols, no, just convert it to aldehydes or ketones and check. Okay, so check what is your answer and let me know in the comments. Choose the halogen which is most reactive towards SN1 reaction in the given compounds ABCD. Okay, which is most reactive towards SN1. SN1, what is the order? Primary is the least, then comes secondary, and tertiary will be more, because SN1 follows 2 steps, carbocation formation and then attack of nucleophile, right? So let's take one by one. It is formed for A, then think about the stability. So here this will be stabilized by the benzene ring, right? So this part can be stabilized by the benzene ring. And what about B? B, I have 2 iodides. If the positive charge formed over here, then that will also get stabilized by benzene, not benzene, the conjugation part. Then what about this bridged compound? So bridged compound, we can't remove BrEA part from the bridgehead position because of the Brett's rule, right? And what about D? D is forming an intermediate of tertiary carbocation, so that is more stable. Case of D. So among this, which is more stable? In A, we have BrA that is stable, and in B, we have IA that is stable. In C, we have BrB would be stable, and D, we have this BrA that is stable than B. Okay. Then the next question, phenol with CHCl3 NaOH followed by hydrolysis and Br in CS2. What is A? What is B? So this is trimer-diamond reaction again, which will give you OH and CHO, right? And Br with CS2, that will produce R1 para-substituted products. Br and OH in the para position, I have Br. So these are the answer to this question.